research is taking place.
Scientists are using state-of-the-art telemetry tags such as this to track the dive profiles of seals, such as dive depth, speed, and water temperature. They then correlate this data with the animal's metabolic rate and heart rate. Seals dive primarily to forage for food. They are capable of diving to great depths. For example, elephant seals have been known to dive to depths up to 2,000 meters for as long as 2 hours. Seals are able to survive such long dives by collapsing their air spaces, lowering their heart rate, and reducing circulation to their peripheries. On a cellular level, they have a high concentration of myoglobin, which allows them to store more oxygen before a dive.
So what they do when they dive is they close off all their peripheral circulation, and their heart rate drops dramatically. So in grey seals in the wild, we've had voluntary diving in wild grey seals where the heart rates drop from 120 beats a minute to 4, and then it's stayed at 4 beats a minute right through the stationary part of the dive. Then you get little bursts of heart beats occasionally during that period, and we think that's when they open up the circulation to some bit of the periphery to stop it going completely anaerobic. It's really dramatic when you see it. And the first time it happened, we had a 32-second inter-beat interval. You're breathing at more than 2 breaths a minute. This thing was beating its heart at 2 beats a minute for a couple of minutes. And we thought the machine had broken at the time. So it's really interesting to watch it happen. And that was freely diving wild seal out in the middle of nowhere. So unless it had a killer whale sneaking around behind it, we think it was completely relaxed. Normal dives for a grey seal or a harbour seal out here, harbour seals are 3 or 4 minutes a dive. Human divers, breath-hold divers, are perfectly capable of doing that. The things that seals can do, humans can do to a large extent. The big difference is that when we took this free diver, she did a couple of dives like that, and then she got on board the boat, shivering, trying to warm up and get rid of the lactate buildup in her muscles. The seals that were swimming around her when she was doing that just kept doing it, and they were going to keep doing it for the next couple of days until they bothered to haul out, or maybe swim out in the middle of the North Sea and keep doing it for a month. It's just their steady state, and that's the big difference. At the moment, in the marine mammal world in general, marine renewables and various types of offshore development, so acoustic issues to do with the Navy, marine renewables, primarily tidal and wave devices, and oil and gas developments are driving a lot of the research that we do. So it's kind of driven by well, not kind of, it's almost completely driven by applied research requirements. We're lucky in that the things that people need to know are the things that we want to know. So we're in a really fortunate position that we can take a lot of that funding and we can apply it directly to the things we want to do.
Yeah. See you for now.